Hi, welcome to my shop. My name is Peter. I'm sitting at my welding table at the moment, and I'm not very sure how this is going to turn out. I've got a very cheap GoPro camera. I think the video quality is probably quite good, but the sound quality is crap. I'm going to do something about that later on, I hope. Let me tell you a little bit about me. I'm 73 years old. I've been around machining and welding for a long time. Entirely self-taught, no formal qualifications at all, but I still think I've got something that might interest you. Now, what I plan to do, hopefully, is a series of videos with something or other made simple. I'll tell you why I came to this idea. I was driving in my car the other day, and I thought when I started the engine up, the engine temperature sensor sent a message to the engine management computer, who then told the injectors the strength of the fuel that had to be injected. And then as the engine warmed up, the engine management computer weakened the thing off, and eventually we got to the full running temperature. Now, I then went to wash the windscreen, and I pressed the button on the steering column stalk, and the washers came on, and the wipers came on too. Now, if I cast my mind back to my early days of driving, we had a little knob on the dashboard called a choke, and you pulled it out. It was all quite simple, and the engine ran with the choke out, and you progressively pushed it back in until you didn't need it anymore, unless you were an old lady that I heard about who kept it out all the time to hang her handbag on. Then I thought about the windscreen washers. When I first started driving, we had a pump on the dashboard. It was just a simple mechanical pump. And you push that, and water came out of the washer jets. And if you wanted to wipe the windscreen, you would press the windscreen wipers. And that was that. And I thought to myself, why do we have to make everything so complicated now? And so that's what I'm going to do, make videos on keeping things simple. Now, the first one I'm going to do, hopefully, is edge finding made simple. Now, that's quite a complex subject, so probably I've bitten off a bit more than I can chew, but I'm going to try. So that's the first video coming up. If that's successful, I will then do another video on aluminium welding made simple. And for the benefit of our American fans, I don't mean aluminum, I mean aluminium. I think I'll probably upset them now. Anyway, that's the way it's going to go. Right, I'm now sitting in front of the mill, and we're going to do some wiggling, or edge finding. Now, the thing I'm going to edge find is this piece of, it's 25 by 25 square solid stock. Now, I've machined it flat with a 20mm end mill. Now, the end mill has got one flute missing, so it's really a 3-flute end mill instead of a 4-flute end mill. It doesn't seem to have any much difference, really. Right, so let's put that in. Before I go on there, I've machined the ends 90 degrees to the workpiece. Now, the reason for that is, and I'm going to show you a diagram here. This is exaggerated, by the way. If it wasn't 90 degrees, then you would have an exaggerated that. and therefore it would depend where you were on the end of the workpiece as to what the measurement was. We want the workpiece to measure the same anywhere, all the way up and down it. Now the other thing I'm going to do is I'm going to measure the length and the width. Now when you do that, if I can get that up high enough, there's the workpiece, but the ball, when it's touching the workpiece, which it will be, there's the center line of the chuck. You can see that the ball is half a ball away, even when it's touching, and the same thing that side. So we will have to subtract half the width of the ball, both sides or both ends, which means that it'll be one ball subtracted from the measured length. Now I'm going to put the workpiece give it a good bash down. I have, by the way, wiped the ends of the faces of the chuck, of the machine vise and the workpiece clean. Now you can see that I've got enough length, which is deliberate, to have both ends poking out, so we can actually get at each end. Right. I'm going to reposition the camera now. That's the DRO, by the way. Now, we've got something we wish to edge find. Now we need something to edge find it with. And I am going to use what is called a wiggler. Just adjusting the camera a bit. Now that is one of those. It's universal joint there and a ball on the end. Now the very important thing you must do before you commence any edge finding is to know the width of the ball, because as I just told you, you need to take off from the measurement half the width of the ball either side. In other words, that's a 5mm ball, so you need to subtract 5mm from the measured length. Right. Just get it up for a moment. Now you need to make sure that the shaft has no run out, which it has, so I put it into the try that. Bingo. So let's move that along a bit. Lock the quill, and here we go. Now you can see that's wiggling nicely. If I move it closer, which will be the opposite way, getting closer, getting closer. Nearly there. And there we go. So now I'm going to press X0 on the DRO. Then we're going to motor along smartly to the other end. I could make it go faster, but it's set for a nice machining speed, so I don't really want to alter it. You'll have to be patient with me. Right, now I'm going to have to move the camera, which is propped up on the box. I think that should be alright. Bring the quill down. Start it wiggling. Getting closer. I'm only moving a very little bit at a time, because the DRO resolves to 5 microns. That's 5,000ths of a millimetre. Getting close. And there it goes. Now I chose this particular sort of edge finder because it does give that nice definite point which is around the edge. The other thing about it is that it's quite narrow, and so you can get it into confined spaces, which can be very useful. Right, now the DRO now says 120.730. So that is the length of the workpiece plus the width of the ball. So we can take 5 mm off that to actually get to the length. There we are. Sorry about all the moving about. Alright, we're now going to do the y-axis. So I'll position the camera where I hope you will see it. It's a little bit higher, in fact quite a bit higher, on several wooden blocks now. I think that should do the trick. Getting closer. And closer. Have to be patient. like fishing, isn't it? Hey, so we will put y0 on the DRO. A bit further down, I think, about there. By the way, I hate fishing. Really boring. A bit like this, really. There we go. So y is 29.400. Right, we're done with the edge finder. So now we've got those two dimensions. L equals that reading -5 for the ball, and W equals that -5 for the ball. Just struggling with my diagrams here. That is L and that is W. So L equals 115.730 and W equals 24.400. Now, supposing that you wanted to find the midpoint there, you'd be tempted to think that it would be half of those two figures, but it isn't, because we haven't told the DRO anything about taking off 5 for the ball. What we've got to do actually is to take the original dimension, that one, before we took off 5, and divide it by 2, and we get my thumb out of the way, we get 60.365, and that one we divided by 2 is 29.400 divided by 2, 14.700. Now, you will be tempted to think that that was half of those two, when in fact it isn't, because we haven't told the DRO anything. It's actually those. So what I'm going to do, you won't be able to see it, but I'm going to go to those two positions on the DRO. So bear with me for a moment. 60.365 for X. We are getting there. Slowly but surely. Slow to do it and sure to make a mess of it. Point. .385, 365. Just check that. 60.365. And on the Y, we need to go to 14.470. It would help if I went the right way. .9. Yeah, 14.700. Now, what I'm going to do now is to press X0 and Y0. X0, Y0. And that should take us to the middle. So I'm going to go and get a Sharpie, and then I'm going to make a Sharpie mark there, and then put a centre drill in it, and that will be the centre drill mark. Right, I'll put a centre drill in. Just check that we are. There we are. That went slightly off 0. Start the thing up. Only want to make a tiny mark. I think that'll do. Now, this is where I nail my colours to the mast, and it won't be accurate with a pair of dark calipers, but and I make that dead on the centre. Oh, we didn't do the other way, did we? Yep. So now we have marked the centre, and now, which is X0, Y0, so now we can actually go anywhere we like on that workpiece with reference to X0, Y0, the centre. Right, let's have a recap before we go any further. I hope you can see that all right. Now, we measured 120.730 and we took off 5 for the ball, So that is 115.730. And same with the width, 24.400. And then we halve that figure, not that figure, because the DRO doesn't know anything about the ball yet. And then we did the same for that figure, and we got that figure. Then we went to those two figures on the X and Y axis, and then pressed X0, Y0. Now, what we're going to do now is to make a mark. We want to go to a point that's 10 in that way and 10 in that way. And to do that, we need to, wait a minute, getting muddled up in the diagrams here. There we are. Now to do that, we can now halve that figure because the DRO does know about the ball. We've got X0, Y0 there. And similarly for the width, will now be 24.400. And so half of the length is now 57.865, and half that way is 12.2. That will take you to the middle. And then we want to take 10 off both of those. So 12.2 minus 10 is 2.2, and 57.695 minus 10 is 47.865. Sorry, I misread it. Right, I'm now going to have to reposition the camera. Right, there's the DRO, and it's on X0, Y0 at the moment. Right, I've now repositioned the camera, and we are now on Y equals 2.2 and X equals 47.865. And just to prove it, I'll show you the DRO. There we are. Now the camera is perched precariously on two wooden blocks and an old paint can. I'm hoping the video comes out all right. Now, I'm now simply going to make a little mark like we did before and see whether or not it comes out as 10 in and 10 along. A bit more perhaps. There we are. Now, I'm going to use a pair of bar calipers to measure it, which I'll set to 10. I think you can see that they'll just come out to 10 in, or along rather, and 10 that way. So, job done. Right, the camera is still precariously perched on two wooden blocks and an old paint can with a bit of scrap on the back of it to stop it from toppling over. We spare no expense in these videos at all. Very high tech. Now, you can see that now we've got X0, Y0 there, that we can go to any place in relation to it and drill any hole pattern we like. All we've got to do is work it out. You can have anything you like in relation to X0, Y0. And I've put a little pointer in the chuck now, and just to prove that we can always go back to X0, Y0, that's what I'm going to do. coming up. 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1, 0.75, 65, 55, 35, 25, 15, x naught. Now let's do the y, which I normally turn the wrong way, which I am turning the wrong way. Gone too far. There we are. Now, that pointer should go in there, which it does. So you can see that you can work any position you like by purely knowing where x naught, y naught is. And if you do the correct mathematics, you can go anywhere you like on the workpiece. So, just to sum up, by edge finding only four in fact faces, that one, that one, that one and that one, we have put ourselves in a position where we can make any hole pattern we like anywhere on that workpiece. Now, a word about the DRO. Don't take any notice about whether it says plus or minus. Whether you're going in the right direction is determined by common sense. You can see whether you're going in the right direction. It might have plus or minus on the DRO, but don't worry about it. Now, one final word of warning. When you think you've finished doing all your machining, don't take the workpiece out of the machine vise until you're certain you have. Otherwise you'll have to put it back in again and start all over again.